Hello everyone, I hope you guys are doing really well. My name is Julian and today let me share one instance, one problem that I faced while I was working with a project with databases. So right now you're comfortable with working with creating a table in a database, inserting values to it, selecting values from it, using aggregate functions on it. So I was also comfortable working with all of these things when I started with SQL. So I was working in a company and I was assigned a task to generate a report that combined the employee information with their respective department details. So initially I thought I just have to find the values from two tables. So it sounded simple enough at first hand. I had two tables. One was the employee table where we had the employee name, their salaries, and the department IDs. And the second table was the department table. In the department table, we had department names and the department IDs. So my task was to display the employee name, salary, and its respective department name in one report. So I decided to handle this task manually by running two separate queries. So let's just say this is one example of the table that I was working with. I've created a replica of the kind of tables that I was working with. So I have one employee table and the other is departments. So let's try to display the value for both these tables from employees and the other from departments. All right, let's try to run this. So we are getting the entries for both the tables, employee and department. So once I had the data from both the tables, I thought I can just manually match the department IDs from the employee table to the department ID in the departments table. And it seemed like a reasonable approach. I thought I'll get the department ID for every entry and then look for that department ID in the department table. So like Alice with the department ID 1 belongs to the department HR, and then Bob with the department ID 2 belongs to the IT department. It seemed like a reasonable approach initially, but quickly I realized how inefficient this was. So as the dataset grew and I started dealing with more employees and departments, the manual matching became very difficult. I had to manually go through each row to match employee data to their correct department. And this approach wasn't scalable. Every time I ran the queries, I had to download the data and process it in my code. So the worst part was that it was error prone. If I missed even one department ID and even made a mistake for matching a department, such as, so with a large set of data, if I am mismatching the David's department ID to IT instead of sales, so it will result into errors inside the database and the entire report could be wrong. It was at that point I realized that I need to find a better way to handle this. After spending a bit of time researching, I discovered SQL joins. So what are these joins? So I learned that I could combine both the tables in one result based on the matching department ID without having to manually process the data in my code. So if we will look at the table once again, the department ID is one of those columns which is common in both the tables. So I decided to make use of these common values and join the table. So by joining the table, the department ID will automatically refer to their department names, and I'll get the name, their salary, and their department automatically. So let's try to see how we can work with joins. Let's look at the syntax for joins. So for working with the syntax for joins, we use select and then we specify the column values that we want to join. So let's say we want to have column 1 from table 1 and then we want to have column 2 from table 2. So we will do select table 1 dot column 1 and then we will do table 2 with column 2 and then we will make use of from the table names and then we will join it with the other table by making use of the keyword join. So we will add join and then the name of the table. And after that, we'll specify on which column we want to make these joins. So in this particular table, we can see that department is something which is common in both the tables. So we can specify those column names. So we can do join the table that we're joining and on which column we want to join. So we will specify on the column names. So on table 1 with the common column and then table 2 with the common column. All right. So this is the syntax. So right now we want to implement the same thing on these tables. So the final query that I used for getting the name, department, and salary, I made use of the select statement, name of the first table, employee dot name, then employee dot salary, and then the department name. So I'll get the department name from department table, department name from the employee table, and then I want to join the employee table to the department table. So I've made use of joins and on which value we want to join. So department ID is one of the common values for both the tables. So we'll try to do on employee dot department ID is equals to departments dot department ID. All right. Let's revise this once again. So we're getting the name and salary from the table employee, and we're getting the department name from the table department. And then we are joining these two tables using the keyword join, using the column department ID. Let's try to run this. All right. So we're getting the name, salary, and department name inside one query. So instead of manually doing the matches for department ID from department name, we have automated that process by making use of joins so that the department ID gets the department name automatically from the department table. So we are having like Alice with the department name as HR, Bob with the department name as IT. And this also made sure that we were not running or making any errors while getting the table and making reports. So the benefits that I discovered was the simplicity. By using a join, I no longer had to worry about manually matching department IDs or writing complex logic. The database handled the combination of tables for me. And it also was efficient. The query was much faster, and I no longer had to manually download and process multiple datasets. Everything was done in a single query. It was also scalable as the company added more employees and departments, so the query still worked perfectly without any changes, where the manual method would have needed constant adjustments. With these joins, I was confident that the data was accurate because it was retrieved directly from the database based on the defined relationships between the tables. So this particular experience that I had helped me get and learn the importance of SQL joins in database management. If I had not discovered joins, I would have wasted a lot of time manually processing data, and likely there would have been more room for errors. So now it is your turn to dive deep into how joins work. So moving forward, whenever you have to work with two tables which have common values within each other, we can make use of joins. In the next section, we'll dive deeper into different types of joins and how they can be used for different scenarios to combine data for multiple tables. So remember, SQL joins aren't just useful, they are essential for handling relationships between different sets of data. So make sure that you're making use of join to simplify your queries and save yourself some more time and avoid errors. I hope you had a good time learning more about joins and SQL commands. Happy coding, everyone.